Hello everyone. Let's start our today video with numericals related to the electric potential and different topics that we had already covered. First question is, a cube of side B has charge Q at each of its vertices. Determine the potential and electric potential due to this charge array at the center of cube. We have to find what at the center of cube we have to find the potential. So if we see, this is the structure of cube. This is the structure of cube. We have to find potential at the center. Potential at the center of the cube. At each vertices, charge Q is placed. Charge Q is placed at each vertices. So what we have to do, first of all, to find the potential, we know the formula, that is K time charge by distance. Charge is Q and distance is from the center. For every charge, distance from center is same. From every charge, distance from the center is same, because if suppose a person is sitting, 8 person are sitting at the corner of a cubical box, then their distance from the center will be same. If we find the potential due to one charge, we just multiply it with the number 8 and it will give the potential due to the total 8 charges presented at the vertices of the cube. So first of all, we have to find what? We have to find the distance of one charge from the center of the cube. Distance of one charge from the center of cube. This is the one face of cube. Suppose one face, front or backward face, whatever you want to take, you take this. One face of the cube. First we have to find this. Each side is D, it is given. Then if it is D, this is 90 degree. This is what? Under root 2 D. Now this is the rest of cube. I'm going to take what? This and this side and this. I'm taken a triangle, front back to front diagonal with back face diagonal, and this side and this side. So for this is, of course, this is both at 90 degree. This is hypotenuse. Now to find the hypotenuse, we take this square plus this square, we get the hypotenuse. Here this is equals to under root 3p. By solving that, we get this p. This is the length of diagonal. This is the length of diagonal. Like now, once we get the length of the diagonal, what we have to do, that we have to take half, because diagonal of the cube is from one end of the one corner of the face to the other corner of other face. So we have to take the half of it. We have to take half of that. For taking half of that, we just divide it by 2. We divide it by 2. So once we divide it by 2, we get under root 3 b by 2. Like for hypotenuse square is equals to under root 2 b whole square plus b square. This is 2b square plus b square equals to 3b square. For hypotenuse, we take the root. This is under root 3b. So this is the length of hypotenuse, but the distance between charge and center O is half of diagonal under root 3 d divided by 2. This is the half of diagonal. So now potential is equals to V is equals to K time charge upon distance. Distance is 3d upon 2. This is potential for one charge. If we have to calculate the potential, total potential for the total system, in total system there are 8 charges. We just multiply it with 8. So we get an answer of 8 time, this is K complete 1 by 4 pi epsilon 2 q by under root 3b. So this is the result. So it's K time 16q by under root 3p. This is the result. So next question is, if one of the two electrons of hydrogen molecule is removed, we get hydrogen molecular ion H2 positive. This ion consists of two protons and two electrons. If at any instant two protons are separated by a distance of 1.5 angstrom and electron by 1 angstrom from each proton, calculate the potential energy for the system. Specify your choice of zero potential. Means what? Sorry for this. It means we were having hydrogen molecule, H2 molecule. We know that in hydrogen molecule there are two protons and two electrons. But we have removed one electron from it, due to which it has become H2 positive ion. H2 positive ion. So this H2 positive ion has two protons and one electron. Now for this particular system is given that two protons are separated from each other by a distance of 1.5 angstrom and from electron by 1 angstrom. So it's like, suppose it's proton 1, this is proton 2, this is electron. Distance between this proton is 1.5 angstrom. E both of plus, electron minus C, distance is 1 angstrom. This is 1 angstrom. Suppose initially here is nothing. First we bring this positive charge, then we bring another positive charge. First, if this positive charge is present, then work done in bringing this positive charge at a distance of 1.5 is U1 equals to 1 by 4 pi epsilon naught first charge, second charge upon distance between them. Now U2, as we have to bring this electron here, minus E at a distance of 1 from each, 1 angstrom from each. So we have U2 equals to 1 by 4 pi epsilon naught, energy between this and this, plus C minus E upon 1 angstrom plus 1 by 4 pi epsilon naught, energy between this and this, plus C minus E upon 1 angstrom. These are in angstrom. If we change it in meter, it's 10 raised to power minus 10, 10 raised to power minus 10. This is also 1.5 into 10 raised to power minus 10 meter. So total potential U is equals to what? U1 plus U2. Just by adding this two, we get total U is equals to U1 plus this U2 complete. So by substituting the value, as E is common from all, 1 by 4 pi epsilon naught is common, we get common this, inside we get this minus sign of E. By substituting the value again, we get this, and by solving, the result is here 30.72 into 10 raised to power minus 19 joule. Now we always keep one thing in mind, that we always have to convert energy of such system in electron volt. We have to convert energy in electron volt. As we always get energy of a result in joule, so after calculating the result, we have to convert it in electron volt, and 1 electron volt is equals to 1.6 into 10 raised to power minus 19 joule. So 1 joule is equals to what? 1 by 1.6 into 10 raised to power minus 19 electron volt. So now you have to do what? To calculate the energy in electron volt, you have to just, if a result, whatever the result you get, divide that with 1.6 into 10 raised to power minus 19, and you will get the answer in electron volt. Another thing you have to keep in mind, suppose if in a question energy is given to you, in a question energy is given and it's given in joule. So the first step is to convert joule into electron volt, then solve rest of the steps of the question. So this is the way you can convert joule in electron volt by dividing the result with 1.6 in 10 raised power minus 19 electron volt. Now next one is just a minute, let me set it. In a hydrogen atom, electron and proton are bound at a distance of about 0.53 angstrom. Estimate the potential energy of the system in electron volt. Taking zero potential energy at infinite separation means initially in the system there was no charge, means if we bring the first charge from infinity to a given point then no work is done. But if we bring the second charge from infinity to the point where the first charge is already existing, then work is done against the first charge, means u1 equals to 0 in this system but ut is not 0. What is the minimum work required to free electron given that its kinetic energy is half of the magnitude of the potential energy? If you have to find the total work done or total energy, that is equals to kinetic energy plus potential energy. For total work done, this minimum or the total work done, that is equals to total energy, and that energy is equals to kinetic energy plus potential energy. Means in second step you have to calculate total energy by placing the value of kinetic and potential. Means first of all you have to calculate what potential as given in the question. Kinetic energy is half of the potential energy, then you have to calculate kinetic energy, then you have to take the sum, then you get the minimum amount of work done or total energy. First is given that hydrogen atom 1 electron and 1 proton. So first of all if you bring the charge from infinity, that's 0, but if you bring second charge from infinity means you have to do work. u1 is 0 here, but u2 is k time proton electron upon distance between them, that is 0.53 angstrom, means 10 raised to power minus 10 meter. By solving this is u2 and total u is equals to u1 plus u2. u1 is 0, u2 is k time e into minus e, 0.53 into 10 raised to power minus 10. By substituting value of e and minus e's value is 1.6 into 10 raised to power minus 19 coulomb. Minus e is minus 1.6 into 10 raised to power minus 19 coulomb. Value of k is equals to 1 by 4 pi epsilon naught, that is equals to 9 into 10 raised to power 9 Newton meter square per kg square. Now by substituting the value you will get the result u is equals to this. This is what potential energy you get here. This is potential energy. Convert this joule into electron volt by dividing this with 1.6 in 10 raised to power minus 19 electron volt. Then you have to do what? Then kinetic energy is always positive, so kinetic energy is half of potential energy, taking half, but don't take negative sign because kinetic energy is always positive. If kinetic energy is negative means that system cannot move, means kinetic energy can never be in negative. Kinetic energy is always positive. So next you have taken kinetic energy half of potential energy, then you have to calculate minimum potential. That minimum potential equals to minus of total energy. Total energy is equals to kinetic plus potential energy, kinetic energy plus potential energy. By substituting the value you get this result. This is the result of minimum energy required. Next question. Charge 8 coulomb is located at origin here. Calculate work done in taking a small charge of 2.92 of minus 2 into 10 raised to power minus 9 coulomb from point A to point B via point C. Means we are taking charge from point A to point B via C. Means like this. But you have to keep one thing in mind, that this energy or work done is conservative in nature. This is conservative in nature. If it's conservative in nature, means it do not depend upon the path followed, it just depend upon the initial and final position. So to calculate the work done, you just need to use this formula: charge into potential difference means VA minus VB. You just have to calculate the potential at point A and potential at point B, and the charge you have to taken. Just by substituting this formula, you get the amount of work done. So potential due to one and potential due to other, you just need to substitute the value and then you get the answer. Means to say, here I am telling you VA is equals to K time charge upon distance. Distance means OA. VB K time charge upon distance into OP. Then work done, say, equals to Q naught K time VA minus VB, VA minus VB, K is common, Q is common, K, Q, Q naught. Inside we get 1 minus OA, 1 by OA minus 1 by OB. By substituting the value, you will get this result. You will get, by solving all values, that K is 9 into 10 raised power minus 9, Q and Q naught value. Then substituting the value of OA and OB, you just get this result in joule. If you can want, you can convert this in. You have to convert this in electron volt. Now, so in this way, you can calculate the potential. And what about the energy you have to require? So this was the solution of it. So you must try different numerical related to this topic by yourself.